All right, you guys, Mr. Dioso here. We're going to do problem number 11 from 8.5, and we're going to go over a few things with regards to the partial fractions portion. We will integrate this at the end after we've gone through everything in there. So we need to take, again, this is number 11. Okay, so we're trying to integrate 4x squared plus 2x minus 1 all over x cubed plus x squared dx. Okay, so we're going to focus in on the partial fraction, and then we'll set up the integration in just a little bit. Okay, so we have 4x squared plus 2x minus 1 all over x cubed plus x squared. All right, so let's take a look at this x cubed plus x squared, and we're going to factor that out. Okay, so we have x cubed plus x squared. That's going to equal x squared x plus 1. Okay, now the one thing that we want to look out for, though, is this squared right here, and it's all by itself. When we are factoring for partial fractions, we want everything, every factor in there. So, like, let's say we had an 8, okay? All the factors that would come out would be 1, 2, 4, and 8. Okay, so in this case right here, all of the factors of this is going to be x squared and x plus 1. Those are all the factors there. You may see something when regards with repeated elements. We're not going to cover that right now, and you don't have to worry about that in this particular one. In order for it to be repeated, we've got to have a binomial with that x squared in there. So right now, don't worry about it. You see it in your book. Let's not worry about that right now. Okay, so we're going to rewrite this, okay, as 4x squared plus 2x minus 1 all over x cubed plus x squared equals a. I mean, it doesn't really matter what order you put it in. Okay, x squared plus b all over x plus c all over x plus 1. Okay, those are all our factors. Okay, right here, right here, right here, right here, right here, and right there. Okay, so now we're just going to set up that numerator. Okay, 4x squared plus 2x minus 1 equals, okay, okay, a clean that up. A times, we have an x squared here, so we've got to multiply that by x plus 1. Okay, we're going to use this as the common denominator. Okay, so we have b, oops, wrong color. So we have b here, okay, and if we notice up top, we need another x, and we need an x plus 1. So we'll have x times x plus 1. And then we have c. Okay, we have an x plus 1 right here, x plus 1. So we're just missing the x squared. Okay, so now we got to go on and start finding out what our a's, our b, and our c is. Okay, so let's start out with finding a. Let's try and use a different color here. So we're going to find a. Okay, so that means first what we have to do is eliminate b and c. Okay, so I'm going to let x equal 0 because that will eliminate our b and c. So we'll plug it in. Okay, so we've got 4. Just going to space this out real quick. Okay. So we're going to let x equal 0. We're plugging that all in to where those x's were supposed to be. Okay. And then we get this for 0, 0, negative 1, a times 1 plus 0 plus 0. Therefore, negative 1 equals a. Okay, so we're getting somewhere. The next one we're going to find is C. And the reason why I'm choosing C is because it's going to be a little bit easier to find than B. Because I can still eliminate A and B in one shot. So what I can do to eliminate A and B is to let x equal negative 1. Okay. So the same thing, we're going to plug the stuff in. Okay, so we're going to plug in negative 1 in there. Okay, so we got negative 1 here, negative 1 here, negative 1, negative 1, -1, -1. Okay. So therefore, we're left with 4 minus 2 minus 1 equals a times 0 plus b times -1 times 0 plus c. Okay, so we're left with 1 equal to c. So c equals 1. Now the last one we need to find is b. Okay, but if we look up here, if we plug in 0 already to eliminate c, we can't eliminate a. If we plugged in -1, we eliminate both a and b. So we can't get b all by itself that way. So what we're going to do is we're going to use our a and our c that we found, and then we'll solve from there. Okay. So I'm going to rewrite this on the bottom underneath because I need to be able to see it, and I don't want to have to keep flipping up and down because I know that will make it harder on your eyes and your brain. So we've got 4x squared plus 2x minus 1 equals a x plus 1 plus bx x plus 1 plus cx squared. Okay, so I'm going to fill in -1 in for a and 1 in for c. So we have 4x squared plus 2x minus 1 equals -1 out here, x plus 1 plus bx x plus 1 plus c. Okay, this x squared, we fill it in for 1. Oops, cx squared, sorry about that. Okay, I made a mistake. This is, c is 1, so it's just x squared. Okay, that's 1. That's why it's just x squared. All right, so I'm going to distribute out 4x squared plus 2x minus 1 equals -x minus 1 plus bx squared plus bx plus x squared. So we got a lot of algebra here going on. Okay, we're going to combine our like terms. We'll bring the ones over. Got x squared here, subtracting it from there. So we'll have 3x squared. Okay, got a 2x, you got an x here. This is going to be plus 3x. And we've got a -1 here, +1, -1 there. That's going to be gone. So -1 plus +1, 0 equals bx squared plus bx. Okay, so again, we're just combining like terms, the left and the right. Okay, so now what are we going to do? We want to get b all by itself. So the one thing we can do is I'm going to let x equal 1. So here we'll have 3, 1 squared plus 3 times 1 equals b, 1 squared plus b times 1. So we're just left with 3 plus 3 equals b plus b. 6 equals 2b. So therefore, 3 is equal to b. Okay. So now we've got to fill this all in. We have our a, we have our b, and we have our c. Okay. So this right here is what we had earlier, and that's what we're going to write down there. Okay, I'm just making it easier so I don't have to copy it all down again. Okay, so that's what we're using. Is that right there? So we'll just fill this in. We're only going to use fill in for this part right here. Okay. So what's our a again? -1. So we'll fill this in. We've got -1 over x squared plus 3 over x plus 1 over x plus 1. Again, it doesn't really matter order. Some folks just like to see, don't like having a positive up front. For us, we'll just have it here. Okay. So that's our partial fraction. And now we're just going to take the integral